Morning, sir.
Good morning. Are you guys happy with your grades? And this is my last instruction. First of all of you are present here. I want the names, please. Go ahead. Yes, Simon. You
Here.
can. Yeah. Next.
West here.
Next.
Gonzalez.
Hello. I can't hear you.
Gonzalez.
Hello?
Gonzalez here.
Your voice is getting echoed. Gonzalez. I don't know.
Gonzalez here.
Okay.
Yeah.
Next.
Williamson here.
Next.
Soto here.
Soto. Okay. Next.
Lane here.
Next.
Carpenter here.
Next.
Zach Rija here.
Okay. Okay. Then.
Jarka here.
Okay. Then.
Governor here.
Okay. Next.
Sheriff here.
Okay. Next.
Here.
Who? Okay. Nick. Okay. Next.
Glasgow here.
Glasgow. Okay. Next.
Janelle here.
Who?
Janelle.
Oh, Janelle.
Yeah.
Yeah. Next.
Powell here.
Walker Powell. Okay. Next. Next.
But here.
I think already you said it, right?
Yeah, I might have.
Next. Cooper Line.
Here.
You already said it, right?
Yes, sir.
Yeah. So why we are missing 4 guys?
Davis is here, sir.
Who?
Davis, sir.
Davis. Okay, Alexis Davis. Hey, I can't see your picture. Davis.
Ishmael Taylor.
Ismail Taylor. I didn't get any of your files. Not Calc2, not PPQ. Makes
You want me to email them to
no,
you?
no, of course not. No, I don't accept any email. Please. You have to submit by in Canvas.
I did.
See, if you submit in email, that means if something is wrong and if I let you know, how can you come to know this thing? If I put some mark or like this, but in Canvas, if you put some balloon, if you click on balloon, you will find the comment. So that's why you all have to submit on Canvas and make sure you are submitting just 2 files. Veer, but I think you are listening to me, right? But Veer. Oh my gosh. Veer Bhatt, where are you? Veer Bhatt, where are you? Veer Bhatt. Okay. I think he just signed up and then after probably he goes to bed.
Sir?
Yes. So let me first finish. So all you guys have to submit just 2 files. One guy, couple guys, they submitted 8, 9 files. It's crazy. How can I take care of 8 to 9 files? It's not possible. Just submit 2 files or 1 file. 2 files are good for me because one is for homework and one is for your exam. So I can grade both the things simultaneously. But one guy, Veer Bhatt, he submitted 7, 8, 9 files. And that is also after multiple emails. I had a conversation of more than, Veer, where are you? I'm just shouting, Veer, where are you? Crazy guy. I think here, Veer, where are you? I'm calling you since last 5 minutes.
Sorry about that.
Where were you?
I was right here.
If you are leaving the meeting, please let me know first.
No, I
Please.
just had to.
Yeah, so what I was telling you that whenever you submit your exam or like this, first of all, you have to just submit 2 files. If you are not able to submit somehow on Canvas, take the help from any one of your colleagues. Ask somebody in our section. He or she will help you out. But you have to submit the files and just 2 files. I don't want multiple files, 8, 9, 10 files. No, I can't do this thing because 35 students plus 10 files, 350 files. It's hard to handle. It's not possible, please. So submit all your homework in time, just 2 files. If you don't know, ask somebody. All are your friends. All are really very good guys. All will cooperate you. Just ask somebody and he or she will help you out. I'm pretty sure. His first exam, and that's why yesterday I extended your time till 9:30 p.m. because 3-4 guys, they were facing some problem submitting your files in time. Anyway, and some of you have not submitted your homework. I put the remark. If you want to lose your points, I can't do anything. I can just remind you. I can extend your time. I can't do anything more than that. And one guy, he did not submit the exam. Even if I extended the time, he did not submit the exam so far. So if you want, if you are not serious about yourself, nobody can help you out in the world. Yeah. If you need the help from somebody, first of all, you need to help yourself first. I don't want to get upset in the early morning over here, but see, whatever I've been doing, that is just for your betterment. But be sincere, guys. Be sincere, please. If you have doubt, if you are not getting any of the points, I'm always here to help you out. But just technology problem, I think you need to figure it out by your own. How to submit the files. Are you going to ask me these type of things? No. Anyway, this is first time, but next time I will not extend the time. Maximum up to 12 noon because it's a owner code. How can I trust you guys? If I allow somebody to submit the file at 9:30 p.m., that means within this 12 hours, somebody can do any kind of mischief. I don't say that you guys are no. I trust all you guys, and that's why I did the same thing. But owner code doesn't allow us. Please trust me, guys.
Sir,
I don't mind to give you extra time. Why should I? No. But we all have to follow the owner code, guys. Please. I don't want to be strict with you. You all are my friends. But simultaneously, we have to follow the owner code, guys. I can give you couple hours more. That's fine. If you are facing some problem, some of the places still lockdown is there. If you are not getting any scanner, some problems are there in the first exam. But I'm pretty sure these things should not be repeated in the next exam. Please, guys, or before the exam, at least practice to submit something on Canvas or like this, or just try to aware of all these technological things. That way you are not helping me, you are helping yourself first. So please do this thing. I told you yesterday, I'm teaching you everything that you can just download one app on your cell phone, that is scanner, and that will allow you to take 10 pages, picture of 10 pages and PDF automatically. You can immediately send it to your cell phone. I've been doing this thing since last 3 months. And it's very easy, very convenient. Suppose your homework contains more than 10 pages. I can understand. In that case, you can submit instead of one file, you can submit 2 files. That's fine. But you know, in my DFQ course, one girl, I don't want to disclose her name, she yesterday sent me more than 17 files. Each page, she takes the picture, she took the picture and she submitted on the canvas. It's hard for me, guys. Please don't give me hard time. It's extremely difficult for all of us, mainly for teacher community, to take care of you guys online. Yeah, it's hard. Yesterday you won't believe I spent 2.5 to 3 hours, because when I could not find any of the files like exam file, test file or homework file, immediately I sent the email to that guy. Immediately I sent the email, and there were multiple communications, more than 5, 6, 7 emails. Do you think that I can reply 10 emails per person for 35 students a day? It's not possible. 350 emails. Who can reply these emails? No, nobody can do this thing. Please try to understand this thing. Try to cooperate us. Please, guys. It's a request. Please. I request you guys, please be sincere. Please. I know you are sincere, but you have to be a little attentive too. You have to be particular too. So please, guys, this is the first time, so that's fine. But next time, please be careful. Be careful. It's easy. It's not that difficult. It's not that difficult. I know it. And all other guys, they did this thing except 2 or 3. So, and I gave you lots of extra points also. I did not mention that thing, but I gave you lots of extra points. If you look at the example like this, and yeah, if you were entitled to get 2 points out of 5, I gave you 3 or 4 like this. I just cut 1 or -1, -1, -2 like this. I just cut 1 or 2 points. So I'm trying my best to help you out, but you have to first help yourself, guys. So please be careful next time. And now let's continue with our with our syllabus. Is it okay, guys?
Yes, sir. Thank you.
It is early morning and I did not want to disturb you. I know it's a very nice time in the morning, and I myself don't want to get disturbed. So, but it's okay, fine. These things are equally important for us. My next question is, did I provide you the practice test assignment for chapter 6? No? Or yes? I will take care of that thing, don't worry. Mostly I will upload that practice test exam most probably today. If it is not there over here, let me just double check. Yeah, chapter 6, and where is the practice test? It's not there. Okay. So we did this thing. These are, you can see over here. Yes, guys, you won't believe. See, I'm trying my best. Yesterday I bought this one for you guys to get here. This is called Wacom. Wacom. And I'm facing some problem connecting this Wacom with my laptop, because you know, so many times I'm just using my white pages and just try to show it to you like this. But Wacom will allow us, if I write something over here, you can see directly over here on the screen, just like our classwork teaching. So trust me, guys, I'm trying my best to help you out. Trust me. Yeah, but most likely, probably by today evening, I will fix this problem. Yesterday I was at VMI. I reached over there at 8:30. Yeah, while you guys were taking your exam at that time, I was driving. And I reached to VMI at 8:30, and then after I left VMI at 7, I came back home at 7:45. Yeah, full day, almost 11 hours I passed over there. Lots of work was there. That's fine. That's my work. Anyway, guys, so let's start with this one. So we went over a few of the integration problems, and they were just simple integrations. Look at over here, x cubed minus x. So you can do the quotient. If you have just single function over here, root x like this, or x square, you can just divide your numerator by denominator, each term of the numerator by denominator, right? But if you have x root x minus 1, I'm sorry, you don't have any other option. So at that time, you have to be very particular. And main thing is whenever you have root x minus 1, root x plus 1, something, some plus minus, some other function is there in terms of addition or like this. At that time, always try to look at the power of numerator and then compare that one with the power of denominator. Your power of numerator has to be strictly less than the power of denominator. If it is higher, always you can go for long division. That's what we did. And then after I gave you another example that was based on the formula. Actually, of course, you can say take sine x equal to u. Sine x equal to u. So sine square x is ux, u square, and sine x is u, means derivative of sine x is cosine x. And you can see over here as a multiplier. After that, I gave you one. After that, I gave you this formula that whenever you have function, irrespective of power, please, function and its derivative as a multiplier, you can play with the constants again. Okay, you can always increase the power by 1. So here it is 2. You can increase the power by 1. So it is 3. My function and power is increased by 1. So sine x and 2 plus 1 is 3. So sine cube x divided by 3. Like this. So sometimes you can get, and you are going to use this thing very frequently in your further courses. I mean to say DFQ or 301, advanced math, or you can say Calc 4. Some people say 301 as Calc 4 or advanced Calc because that is the vector valued function, derivative of a vector valued function in Calc 3, but the integration is not, integration is there. And function of 2 variables. In Calc 3, you are going to go only up to derivative for the function of 2 variables, but not the integration. But in in 301, advanced math or Calc 4, you can say, in which you are going to learn the integration for the function of 2 variables. So these are some things, Green's theorem, Stokes theorem, like this. Anyway, so these are the things, right? But here right now we are dealing only with the function of 1 variable, so you don't have to worry about it. Okay, guys, and then after you can see over here, sometimes some simple u substitution will provide you the answer immediately by using the formula set. And same here again, tan x equal to u, so derivative appears over here as a multiplier. So you can either use the formula or you can use u sub. Both will give you the same thing. Jonathan Soto, are you here?
Yes, sir.
Please. Okay. Then after, if 3 to the power 3x, if you take 3x equal to u, e to the power u is e to the power a to the power x divided by ln of a. So we can use that formula. You can take the, and then after, you can go for the answer. And then after we took different ln examples, ln of x cubed by 3, 1 over x times ln x square. I gave you one example for cube like this. This is just the revision because we did this thing on Friday before 4 or 5 days. And just that's why I just would like to repeat some of the things so that we can maintain the continuity. And then after, as I told you, xx ln cube 4. So I think you can manage these examples. These are very simple. Then after I told you that, see here, simply x is there. So you can go for each term division, each numerator term is divided by the denominator and you can go for the answer. Or power of numerator is greater than or equal to denominator, so long division. Okay. And then after some standard formula, 1 over x times square root of x square minus a square dx is 1 over a secant inverse absolute value of x by a plus c, like this. So article 6.1 we finished last time, and there are some not typical but some different kind of examples are there. I just put the star. Star means you need to pay a little bit more attention for those examples, right? Star means you need to put a little bit more attention. So you can see over here, I just adjusted my numerator because denominator derivative first term we are getting over here and rest of the terms I just merged with the other part. So that's how you can get the answer for this one. One more example like this, that I just converted my denominator in the form of 1 over some x square minus a square form or like this. Look at over here. square root of x square minus a square form. And that is ln of 1 over square root of x square minus a square is ln of x plus square root of x square minus a square. So I use that formula over here. So different formulas I have used for the different examples. There is no specific rule that you can use this formula for this one. No, you will come to know this thing only by practice. So you have to practice all these examples. These examples are, of course, not enough. You need to practice some more examples too. Again, let me remind you, I'm going to post few examples for the homework very soon. And please work with me, guys. Don't keep the things pending, please. And then after we went over this one, so always you can, whenever there is no square root sign and square is there, always your intention is to use the arctangent formula, tangent inverse x. That means you have to have 1 over x square minus a square form. So I just made the perfect square and x square minus a square form. And you can see over here, tangent inverse of 1, how to find tangent inverse of 1, tangent to negative 1. That is explained over here. So tangent inverse 1, suppose you don't know tangent inverse 1. So I can say like this, tangent inverse 1 equal to x, and I'm looking for this value of x. So if I take the tangent function both the sides, so tangent x is tangent and tangent inverse will get cancelled out and 1 is left out. So tangent x equal to 1, but tangent x is nothing but sine x over cosine x. So which value of x will provide you this quotient equal to 1? Of course, if I just go for the unit circle, page number 2 on your formula sheet, sine x over cosine x. If I take x is equal to, suppose, pi by 4, sine pi by 4 is 1 over root 2, cosine pi by 4 is 1 over root 2. 1 over root 2 in the numerator and the denominator will get cancelled out and you're going to get 1. So x equal to pi by 4 satisfies this equation, means this x is nothing but pi by 4. So tan inverse 1 is pi by 4. So that's why I plugged out. I just plug the value over here, pi by 4. Same here, you can find tangent inverse negative 1 is 3 pi by 4, right? Suppose somebody says that, how can I take care of this negative 1? Okay, fine, that's not a big deal. Negative 1, that means, look at over here. Tangent inverse negative 1. Suppose I don't know. Here I chose x, let me choose over here y. So that is my y. So it's tangent inverse negative 1. That means if I multiply both the sides by just like this one, tangent function, so tangent y equal to negative 1. But tangent y is nothing but sine y over cosine y. Sine y over cosine y. So which value of y will satisfy this equation? Look at over here, sine y. And of course, we know that whenever you have negative sign over here, just focus first with the positive sign. So suppose I have 1 here. 1 means sine pi by 4, just like previous case over cosine pi by 4 is 1, right? But I want negative 1. That means negative 1, that means either this numerator or denominator should be negative. Am I right? So if I'm getting, suppose y equal to negative 1 over root 2 value, here it is 1 over root 2 value, so I'm getting negative. Or vice versa. Suppose I'm getting sine y equal to 1 over root 2 and cosine y equal to negative 1 over root 2, I'm getting this one. That means any one of these functions should be negative, right? And that is possible only second and fourth quadrant. Either second quadrant or fourth quadrant, because second quadrant cosine is decreasing, fourth quadrant sine is decreasing. In first quadrant, all are increasing because all STC rule. Tangent is increasing, means sine and cosine both are simultaneously decreasing or increasing. So that's not going to work over here. Only either this quadrant or this quadrant will work. Let me start with this quadrant, right? Because we are always moving like this. So let me first take care of this part. So sine of pi minus pi by 4. Why pi minus pi by 4? Because here, look at my cursor. Here to here is angle pi. And pi by 4 makes exactly 2 part of this quadrant. So this angle pi. So pi minus pi by 4, that is this quadrant. Right? Now pi minus pi by 4. Now it is sine of pi minus theta like this. Because it is second quadrant, all S means sine increasing. Sine increasing means sine pi minus pi by 4 is sine pi by 4. So sine pi by 4. But cosine is decreasing. Only sine is increasing. Cosine is decreasing. So cosine pi minus pi by 4 will be negative 1 over root 2 because cosine is decreasing. So it is negative 1 over root 2. So you can see over here sine pi by 4, 1 over root 2. Negative cosine pi by 4 is negative 1 over root 2. Right? So pi by 4 satisfies this equation, and that's why actually pi minus pi by 4. But what is pi minus pi by, because this is my x, so or y. Y is equal to pi minus pi by 4. If you take the LCM, 4 pi minus pi divided by 4, so 3 pi by 4. So actually, whenever you are working with pi minus pi by 4 means simultaneously, it is to be understood that we are working with 3 pi by 4. So my value of y over here, that is 3 pi by 4. So sine 3 pi by 4 is 1 over root 2, but cosine 3 pi by 4 is negative 1 over root 2. Look at here, I did everything for you. And that's why we are getting negative 1. So just go back and plug that value over here and then take the LCM. So pi minus negative 2 pi by 4, negative pi by 2 is the answer. So sometimes in some examples, you have to be a little bit careful about your unit circle and how to find the angles, right? Just be particular. Just work with the unit circle. If you have some doubt, you can ask me over here. You know, the best thing of learning is mainly whenever we are learning online. At that time, the best thing is whatever I am teaching here for 2 hours, 1.5 to 2 hours, just spend at least 2 hours, 3 hours the same day. Try to convince yourself. If you are not convinced, that's fine. I can understand that thing. Just keep your doubts aside, write it down on a separate piece of paper. And next day before we class, next day when we start our class, at that time you can say, sir, we have some problem. I don't mind to discuss with you daily. Yes, I don't mind to discuss with you at your span 10, 15 minutes just for your doubts. I don't mind, that's fine. Rather than, I would say, I would appreciate you guys that you are working with me, you are following my instructions. And that would be a good revision. Every day morning at 10, 15 minutes, whatever you guys have done yesterday, if we have revised this thing, that would be a good revision for all of you. But for that, you need to work with all these stuffs. Because without working this one, you will not find any doubts. And if you don't have any doubts, there is no point of revision. Revision means just discussing about your doubts. Am I right, guys? Are you getting me?
Yes, sir. Thank you
Yes,
very
sir.
much.
I'm very friendly, guys. Only thing, I'm getting upset whenever you are not getting good grades, whenever you are not performing well, whenever you are not following my instruction. Because I am doing all these things just for you guys. Just trust me, guys. Suppose you are passing this course with A grade. Am I going to gain anything? No. Suppose you are failing this course. Am I going to lose anything? No. But you know, it's a mental satisfaction that if you teach somebody, if you teach your students, and if they are doing well, we are getting a kind of satisfaction. Okay, our students are doing well. And that is good for your career too, right? So please follow me, guys. And there's a reason sometimes I don't like to teach 100 level course. That's the reason, but that's fine. This Calc 2 is okay. But some of the courses, students are really very immature at that time. So be careful, guys. Okay, and then after, I think this was the example, page number 17. We stopped here last time. Suppose I ask you one example, 1 over x minus 1 square root of 4x square minus 8x plus 3. If you look at this example, first side it says that how can we take care of this example? See? It looks awkward. How can you think about this example? But whenever I have one function over here, second function in the square root form like this, always my mind will go in the direction to use secant inverse formula. What is secant inverse formula? Integration 1 over x times square root of x square minus a square. Agree? I have x outside, see, with power 1. I have square root of x square with somewhere over here. And I want x square minus 1 formation over here inside the square root sign. If I think like this, now I have to use my algebra skill and try to arrange my function in that direction, so that in that setup, so that I can use my formula. So if I write like this, suppose x minus 1 as it is, but if I take 4 common, now if you want to take 4 common, you don't have 4 here. But I want 4 common because I can get 4 from here. But what's about this term? So that's why we just divide and multiply it by 4. If you divide and multiply it by 4, right, divide and multiply it by 4. That means what I'm going to get here, it is 4, and so 4 3s are 12 divided by 3, like this. Are you getting me, guys? Right?
Yes, sir.
If you don't want to do that thing, that's fine. You can write like this: 4x square minus 8x plus 3. Plus 3 can be written as plus 4 minus 1. Agree? Plus 4 minus 1. If you write plus 4, so 4 in first bracket, I can take 4 common. And minus 1 I want separately because my formula demands minus 1, x square minus 1 formation. So once I have 4 over here, I can take 4 common. So x square minus 2x plus 1 minus 1. But what is this? This gives us x minus 1 whole square. So I have x minus 1, I have x minus 1. If I use now the substitution, u sub, suppose u equal to x minus 1, I'm going to get u 4u square minus 1, right? u 4u square minus 1. Look at over here, u equal to x minus 1. Still, my formula is not set up according to the, I mean, say my integral is not set up according to the formula because this 4 is bothering me. So what I'm going to do, see, look at over here, this 4 is bothering me. Am I right? 4 is bothering me because my formula, see, look at here, I wrote it down your formula too. Whatever the function you have here outside the square root sign, you have to have the same function inside the square root sign with square. Just square, but the coefficient has to be 1. Has to be 1. My coefficient is not 1 so far. Are you getting me, guys? This is 1 by 4. That's fine because this is my a square. This is not just simply 1. This is my a square. I can take this 4 out. If you take this 4 out because of this square root sign, you are taking just 2 out. And that's just a constant. You can just pull out of this integral sign. So it is 1 by 2, 1 over u, square root of u square. And you are taking 4 out, so divide by 4 here. Or you can divide and multiply it by 4 here so that you can take 4 out from this one. So now you are getting u square minus 1 by 4. Means u square minus 1 by 4 can be written as 1 by 2 square. John Marcel, are you okay?
Yes, sir. I'm just paying attention, trying to figure it out.
Okay. So what I'm going to do, I'm just dividing and multiplying by 4 here. And I took this 4 out. So outside it is 2, 1 by 2, and u square minus 1 by 2 square. So u square, oh, sorry. So you can see over here, see, I'm getting something like this. And my a equal to 1 by 2. So it is 1 by 2 square. Now it is exactly in the form of my formula. So 1 over square root of x square root of x square, 1 over x square root of x square minus a square form. So integration is 1 over a. So 1 over a is 1 by 2. Secant inverse absolute value of x. Here it is u divided by a, 1 by 2 plus c. Indefinite integral, so plus c. Yesterday, I asked you in the exam the definite integral. All the examples, the range was provided to you, even though one student, I don't want to disclose he or she, but used constant c and did not use the fundamental theorem of calculus. Second fundamental theorem of calculus, that is for the definite integral. So guys, be particular, please. So now it is secant inverse and 1 over a equal to a. So u equal to x minus 1 because it was my substitution plus c. That's the answer. Simple, guys. So I'm just teaching you right now, how can you look at the example? See, as I told you that whenever you have this example, that means immediately it should click in my mind that I have some x formation over here. I have x squared. So I don't have any other choice except 1 over x squared of x squared minus a squared form. A square formula. And I set up my example accordingly so that successfully I used that formula to get the answer. Any doubt? Any doubt? Okay. Another example, 1 over 2x minus x square. This is the simplest one. Here it is x I can visualize as root x times root x so that I can take root x out, root x times root x. And again, it is 1 over x square minus 1 kind of formula. Look at over here. So I can take this 2x, root x minus 1 equal to u. And let's see which type of formula we are getting. If you take 1 over 2 root x minus 1, so 2 is constant. Root x derivative is 1 over 2 root x. Derivative of 1 is constant 0. So derivative of 1 is 0 and dx equal to du. This 2 and 2 will get cancelled 1 over root x dx. So this 1 over root x dx, whatever I'm having over here in this, look at over here, this figure, this picture, that is nothing but my du and 1 over u. And that means it is absolute value of ln of absolute value of u. Plug the value and get the answer, simple. Right? And today we are going to start the new article, that is integration by parts. Integration by parts. Now guys, look at over here, whatever examples we have discussed so far, whether it is last chapter of Calc 1, simple integration techniques, or article 6.1, or some of the examples we have done in your article 6.1. All these examples, they were just given in the form of addition or subtraction or kind of, addition and subtraction form. But we did not go over any of the examples in which we are looking for the integration of two functions in the numerator. I mean to say the product of two functions. Because I told you very first day that integration is not linear in multiplication and division, because derivative is not linear in multiplication and division, and that's why you went over the product rule and the quotient rule for the derivative in your Calc 1. Integration is nothing but the antiderivative, so naturally once derivative is not linear in multiplication and subtraction, so for the integration. And that's why we need to go through some special rule that is called the U into V rule. Sometimes it is called the integration by parts. We are taking the integration of one part and taking care of the other parts. So like this, and that's why it is called the integration by parts. We are making this product of two functions in two different parts. Sometimes three different parts. Depends how many products you are given. How many products are given, it depends on that one. So main thing is whenever it is U into V rule, see, it's not equal to integration of U times integration of V, means it's not linear. Not linear. As per example, suppose I have x squared sine 3x. So this is my x squared, this is sine 3x. So I cannot take the integration of this and this. No. So the question is, how can I get the integration? So integration can be obtained like this. Look at here, guys. First of all, you need to go through this Liet rule. L-I-A-T-E. Liet. If you look at the first term, and that's why I use the capital letters, L-I-A-T-E, Liet rule. Right? So whatever function comes first in your product, that would be your U, and the second function will be your V. So always keep in mind this thing. First function in this Liet rule has to be your U. The second function will be your V. Right? And the rule looks like this. U times V equal to whatever you have decided, you have fixed according to this Liet rule. This L stands for logarithmic function, means it takes something like this, ln x square, log of 2x, something like this. These are the examples of these log functions. Inverse function means any inverse function, sine inverse x, cosine inverse x, like this. Arithmetic function means x square, x cube, and so on. Trigonometric function, sine x, cosine x, secant x, tangent x, cotangent x, etc. Exponential function, e to the power x, e to the power 2x, like this. You know that logarithmic function and exponential functions, they are the inverse of each other, and that's why whenever logarithmic function stands first, exponential, because it's inverse, exponential must stand at last. Right? So every time we are following our previous rules. It's not like this that randomly these things are created. No. There are some sense behind this thing. Okay, there are some senses behind all these things. Anyway, so integration U times V equal to U function as it is, and take the integration of the second part. Minus always. Use the sign of integral. Take the derivative of first function, and this integration, exactly integration again over here. So you are getting two integrals. One integral here, big integral and integral. So first take the integral of this one, product of this one, whatever you're going to get over here. Then after go for the integration of this one. So first of all, always try to solve the most inner function first, right? In your book, this formula is not given. I'm very much comfortable with the first formula. In your book, this second formula is given. But both are same, trust me. Your book says that consider one of the functions as your u, second function not v, but say dv. So take the derivative of that function. Second function is your dv. Then the rule is same, u as it is, u as it is. Integration of second function, but in dv and integration of dv is simply because integration of d and v, derivative and antiderivative reverse process will get cancelled out and you are getting simply v. So you are getting just simply u into v, minus integration, derivative of the first term, integration of the second term was your dv. So dv, again derivative integration will get cancelled, so u dash v. So you are getting u times v minus u dash v. In your book, this formula is given, but both the formulae are equal. Okay, guys, you can use either one. I'm usually comfortable with first one because in that case, I don't have to fix my dv over here. I can say u into v, and then after I can directly take the integration over here. But it is your choice. You can do both ways and you will get the same answer. Okay, as per example, suppose I give you x squared sine 3x dx. Which one will be my u and which one will be my v? Look at here, x squared is my arithmetic function, stands before my trig function. This is my trig function. You can see arithmetic function and then trig function comes. So that's why this arithmetic function x squared will be considered over here as u and my trig function will be over here. That is my v, right? Trig function, my v. And you can directly apply this formula, or you can take the derivative of sine 3x is 3 cosine 3x and you can apply the second formula. Same thing, guys. Okay. Evaluate x times cosine x dx. X times cosine x. X is my u, cosine x is my v, arithmetic function, algebraic function you can say, or you can say arithmetic function and trig function. So u as it is, integration of cosine x, second v function, that is sine x, minus sine under the sign of big integral, derivative of u, whatever you have, derivative of u is 1 and derivative of x is 1, right? Because u is x. And integration of v, integration of cosine x is again sine x. So 1 times sine x is sine x. Once you solve your inner integral, then after go for the outer one. So integration of sine x is negative cosine x. This negative will become positive. So positive cosine x plus c. So x cosine x plus cosine x, x sine x plus cosine x plus c. That is the integration of this term. Now look at here, guys. Of course, you can go for this one, this formula. And so many times this formula will work for all the examples. But there is another formula that is called the tabular form. But there is a restriction for the tabular form. Ismail. There is a restriction for the tabular form. This tabular form will not work for all kind of products. Okay, whenever suppose you have some trig function over here, in that case, it is hard because derivative will go on, continue, and here also derivative or integration, or suppose exponential function e to the power 2x. So e to the power 2x, then 2e to the power 2x. So it will be continuing up to infinite time. Same here, integration will be continued for infinite times. At that time, this will not work. But whenever you have, suppose, if you look at the example, and if you think that you can stop at some certain stage, 3, 4, 5th derivative, at certain level, suppose you are getting 0, if means you can stop over there. In that case, you can use the tabular form. So tabular form is useful whenever your function product looks like that derivative of one of the functions or integration, mainly derivative, will be 0 after certain stage. I want to solve the same example using the tabular form too. So my x is u, so let me write u equal to x. And my v is cosine x, so let me write v equal to cosine x. Guys, all you guys please pay attention. All you guys please pay attention. So v equal to cosine x. So take all the derivatives of x over here. Derivative of x is 1, derivative of 1 is 0. So take the derivatives of u. And that's why I wrote it down d by dx. And take all the integrations. See, I put the integral sign over here. All the integrations of v. Because if you look at the formula, if you look at this formula, look at here. V is not related to any kind of integration, any kind of derivative. See, integration is there, integration is there. But u is as it is, and then after derivative of u is there. So u relates with the derivative. So take all the derivatives of u function and all the integrations of v function. So integration of cosine x is negative sine x or positive sine x. What is the integration? Positive sine x, right? Derivative of sine x is cosine x. Derivative of cosine x is negative sine x. Integration of cosine x is sine x. Integration of sine x is negative cosine x. Always, always, always keep in mind these 4 things. So many times people are getting confused. They are making mistakes in this integration and derivatives of sine and cosines. So integration of cosine is sine. Integration of sine is negative cosine. Integration of negative cosine. Cosine is sine, so negative of sine x. I stopped over here. You need to stop. Whenever, see here, you are getting first step, first is given, then first, and first, second, and third, right? At third level, you are getting 0. You have to go over here for one more level. Here it is third level, so you have to go up to 4th level over here. So cosine x, second term, third term, 4th integration, and then stop it. Now, what are we doing here? Simon? Raise Simon.
Yes, sir.
Okay. What are we doing here? What are you doing here? Multiply your x by, see, look at this one, these arrows, this one, this one, this one. Look at these arrows. Multiply your x by sine x. Leave the first one. It's a kind of cross multiplication, crossing like this. Then 1 with this one, negative cosine x. Then 0 with negative sine x. And you have to start with positive sign, and every time it's alternating signs. So positive, then negative, then positive, then negative, like this. So x multiplied by sine x is x sine x with the positive sign. I'm getting x sine x, positive sign. Then 1 multiplied by negative x is negative cosine x, multiplying by negative sign, so positive cosine x. So positive cosine x. And then 0 multiplied by sine x, doesn't matter, just 0, so plus c. Do you think that both of them are same? Both the ways I'm getting the same answer? Yes or no, guys? Are you getting me or not?
Yes, sir.
I'm asking all of you, are you getting me or not?
Yes, sir.
Yes, sir.
Good. Any doubt in this tabular form, girls? Or in general, into V rule, girls?
What'd you say?
Any doubt in this rule?
No, I'm good, thank you.
No problem. May I proceed further, guys?
Yes, sir.
Okay, so let's go for, now let's solve some examples, okay? Different examples. Nick Tone, are you feeling sleepy?
Sorry, sir. I'm here, so it's all.
Good, good. Ismail, where are you? Ismail. See, I told you, if you are leaving the meeting, please let me know first before you leave your seat, before you leave your chair. And now he started ignoring me.
Sir.
He won't like if I will be upset. Nobody likes it, right? And see, he is not here since last 7 minutes, yeah? He just left.
Sir.
And that's the reason I want to look at your videos. That's the reason. Of course, I want to see your smiling face early morning. It makes me happy. Veer, where are you?
I'm right here, sir. I don't know if you can hear me.
But yeah, now I can see you.
Can you hear me, sir?
Yes, I can hear you. I can see you. That
Okay.
guys,
My
Rachel is
laptop died.
there. Thomas,
I had to go grab the charger. So I'm sorry about that.
Thomas, are you good?
Yes, sir.
Williamson, okay. Walker Powell, good, right?
Sir.
Heavener, T. Heavener,
Yes, sir.
good. Then Andrew Jarka, are you good? Andrew Zarka,
Sir.
good. Alexis Davis, I just heard her voice, that's good.
Yeah. Hi.
Hi. Cooper Lenny. Cooper, are you okay?
Yes, sir.
Simon is good. Ismail Taylor is still not here, see? It's been more than 10 minutes. Yep. Started this tabular form and he left. Before that, he left. Jonathan,
Actually, sir.
yes.
I don't know if this is just because my laptop died in the middle of you speaking, but I didn't really get this. Could you just explain it one more time?
Who is there? Cooper?
Veer, sir.
Veer. Okay. You need to fix your laptop. Veer. So many times I found that you are offline or your video is not working. So many times I found these things. So please fix this problem. Okay, I will explain to you. No problem. Okay, Jonathan Soto, are you good?
Yes, sir. All good.
Very nice. And Judith, I can't see you. Judith Gonzalez, because she left. Judith Gonzalez. Peyton,
Here, sir.
good. Caleb Carpenter, I can't see your face. I can see your ceiling. Now, here you go. And who left out? Maza? Hilwe? Maza. Maza, are you okay?
Yes, sir, I'm okay.
I can't hear you.
Can you hear me now?
I can hear you now. Good.
Okay, perfect.
Judith, still I'm looking for you. Judith and Ismail. It's been more than 15 minutes. These guys are not here. See? Yeah, that's my experience, guys. Sometimes, in the early morning class, people just start the video, sign up, and then after they close it and go to bed. Yeah, and wake up after an hour. That's not allowed. A synchronized class, right? Judith Gonzalez. No. Anyway, that's good. Let's continue, guys. Okay, first of all, let me again explain to you. Whenever we are using the tabular format, take all the derivatives of your u function till you are getting 0 and all the integrations of v function. You have to go for one more integration than your u. Suppose you are taking derivative 3 times. So here it has to be 4 times. Suppose your derivative goes up to 5 times. You have to go up to 6 times for your entire derivative. and then go for cross multiplication like this. X multiplied with sine x, 1 multiplied with cosine x. Just leave the first term like this, here, here, and here. And you have to start with the plus sign and then change the sign alternatively. So plus, minus, like this. What is this? Who is there? Oh my gosh. Thank you.
Sir, I have a question.
Let me finish this one. So x multiplied by sine x plus sine. So x sine x, then 1 multiplied by negative cosine x, or negative cosine x, and negative positive, and 0. You left your chair without informing me. Since last 15 minutes you are not here. Just in the beginning of this class, I told you that if you are going to leave your seat, please let me know first. If you don't want to follow, tell me, I will not take care of you. Tell me. Be very clear, please. Otherwise, remain present over here. Is it okay now? Ismail Taylor, I'm asking you.
Oh, yeah, I'm good.
No, but I'm not good. Be sincere, guys, please. If you are leaving the meeting, please let me know first. I can understand, but not for 10-15 minutes. Okay. Question. Somebody asked me the question. Go ahead, please.
Can you explain one more time how you know how many you have to do for the derivative integral in tabular form?
Until you get 0 over here for the derivative term.
Uh,
You are getting 0 over here at the fourth stage. Go up to 5 integrals, 1 more over here.
Okay.
Okay. And then go for the multiplication. This is the easiest way. I'm not going to ask you any type of formula like this. Yeah. But again, there are some restrictions for this one. As I told you that suppose u equal to e to the power x and v equal to cosine x. Derivative of e to the power x, e to the power x, etc. So many times, infinitely many times. Cosine x integration will go cosine, sine, cosine, sine, cosine, sine, plus minus sine. Infinite times. That this tabular form will not work. Okay, so it's a little restriction for this one. Anyway, guys.
So sir, I see where you have sine x squared.
Who is there? Kabel, I can't see your
This
face.
is Veer.
Okay.
Veer. It's Veer.
Veer. Kabel, I can't see your
Yes.
face. Carpenter. Set up your video first. Yeah. Yes, Veer, go ahead.
I see where you have x times sine x and then cosine x, but I don't see the negative sine x. So do you not use that?
Why you
That
want
last term?
Oh my gosh.
I'm just asking.
0 multiplied by sine x. What is that?
Okay. So you don't. Okay. Gotcha.
Why you want to write 0? If you want to write, I don't mind. Okay.
No, I'm just asking. I didn't know how this worked.
Yeah. So 0 multiply this one, this with this one, this with this one. 0 multiplied by negative sine x. So it's just 0. That's why I did not write over here. Make sense? And you can keep.
Yes, sir.
Okay. See here. Now intentionally I took this example. Look at here. E to the power 2x, e to the power 2x, 2e to the power 2x, 4e to the power 2x, 8 to, how many times? Infinitely times. Integration, cosine 3x. What is the integration of cosine 3x, guys? Where? What is the integration of cosine 3x? Where? I'm asking.
Cosine 3x. Wouldn't I'm not sure, but wouldn't it be negative sine something?
Wrong.
Yeah.
Yes, Lazara? Integration of cosine 3x.
Yeah, I'm not sure. I'd have to look at it.
Your turn is over, please. Lazara, go ahead.
Okay.
What is the integration of cosine 3x? Anything in your mind? Any clue? No. Simon? Peton? No? Okay, write down a separate piece of paper. All you guys write it down. integration cosine 3x dx. All you guys, please write it down. Integration cosine 3x dx. Okay, now look at me, please. On left side, you write down integration cosine 3x. On right side, write down derivative of cosine 3x. D by dx of cosine 3x. First of all, give me the derivative. What is cosine 3x? Derivative? You know the derivative. Don't say no, please.
3.
What 3?
You said derivative of 3x.
I said derivative of cosine 3x. Listen to me carefully, please.
So sine 3x over 3.
Derivative of d by dx of cosine 3x. How can you find the derivative of cosine 3x? Who said sine 3x by 3? Anyway, guys, your Calc 1 course, how can you find the derivative of cosine 3x?
You have to do chain rule.
Good, chain rule. Who said this thing? Peton? No?
Me, sir. Sheriff.
Chair, okay. Yeah, chain rule. So first of all, I can consider 3x equal to u, right? 3x equal to u, you can say. So derivative of cosine 3x is, what is the derivative of cosine u? Is negative of sine u. Agree? And derivative of sine u, d by dx of u. That is equal to negative of sine u, and d by dx of u is your 3x. So that is equal to negative of 3 times sine of u was 3x. So don't you think your derivative will be like this? I'm taking derivative right now. Look at over here, your Calc 1. It is not my part, please. Are you getting me?
Sir, we can't really see the paper.
Can you see this paper now?
Now it's not there at all, sir.
Not at all? Oh my God. How can I do this thing? Just wait. Okay. Now?
That's better.
Yes.
sir. Better.
Agree, guys? So that is called chain rule. That is called chain rule. Now, cosine 3x integration, I ask you guys. If I take 3x equal to u, let's come to the left side. So 3 times dx equal to du. So dx equal to 1/3 of du. So integration of cosine 3x means it is now cosine of u and dx is 1/3 of du. Am I right like this? Am I right, guys? Can I write like this?
Yes, sir.
Get here. Yes or no?
Yes, sir.
Okay. So what is integration of cosine u? Use the formula C. That is equal to sine u plus c. Agree?
Yes, sir.
But what was your u? 1/3 sine of 3x plus c. Agree? Shall I get like this? Girls? Girls?
Yes, sir.
Good. Yes or no, guys? Now, can you please compare these two formulas? I am teaching you this thing because you will be using this thing so many times in the future. Mainly in DFQ course. At that time, if you are going to use this U sub, people will laugh at you because it's time consuming and you are going to get this thing in the middle of the example. If you at that time, if you are going to use U sub in the side of the paper, means you are wasting your time. That's why I'm teaching you this thing. Can you please compare this both of these things, derivative and integration? Here, you know, again, derivative of cosine x is negative sine x. Agree? So negative sign must appear for the derivative. Integration of cosine x is simply sine x, positive sine x. Agree? So there should not be any negative sign. Agree?
Yes, sir.
Oh my gosh. Yeah. Right? In derivative, you can see over here, so negative sine x, here my x is 3x. So negative sine 3x derivative, and I multiplied by 3. Look at over here, whatever the angle was there, because I used the chain rule, and derivative of 3x is 3. So I multiplied by 3. So negative 3 sine 3x. My sine 3x is an angle, remains the same. Integration of cosine is sine, so sine 3x is angle, remains same. But as I told you, derivative and integration, they are the reverse process of each other. And that's why here you multiplied by the constant for derivative. Here you have to divide by that constant for integration. It is sine 3x divided by 3. Am I right? Am I right?
Yes, sir.
Okay, guys. Now look at here.
Yes, sir.
What is, okay, I give you the example. What is integration of sine 2x dx? Integration of sine 2x dx. Integration of sine, forget about sine 2x. Integration of sine x is?
Cosine.
Cosine x.
My gosh. Integration of sine x is?
Negative cosine, sir.
Negative cosine. So first of all, let me write it down, negative of cosine 2x. And what is my angle is x. What is the derivative of 2x? 2. Agree?
Yes, sir.
For derivative, we multiplied by this number. For integration, we divide by this number and plus c. See here? I don't have to go for my u sub and everything. I can do this thing very immediately. Yes or no?
Yes, sir.
Yes, sir.
Yes, sir.
Good. You will be using this thing so many times in future, guys. Please be careful. Please. Good. So my next example is this one, e to the power 2x and cosine 3x. E to the power 2x, derivative goes up to infinity. Integration. Cosine 3x, sine 3x by 3. See, now I'm taking directly. Cosine 3x, integration, suppose it is simply u. Cosine u, integration is sine u. Angle is 3x, derivative is 3, so divide by that number. Again, 9, like this, and so on. So never ends. Agree, guys? Never ends.
Yes, sir.
Yes, sir.
So what I'm going to do, be careful, guys. What I'm going to do, whatever integral I'm looking for, I would like to say this as I. And I can say, because this is my exponential function, always stands last in Liet rule. So this is my v and this is my u. Cosine 3x is u. Formula. Tabular form will not work here now. So formula. Cosine 3x as it is. Integration of e to the power 2x is e to the power 2x divided by 2. Agree? Just like this one. See, integration of, sorry, d by dx of e to the power 2x is, what is derivative? Look at here. What is derivative of e to the power 2x? What is derivative? E to the power 2x. 2x is u. So derivative of e to the power u is e to the power 2x, and derivative of 2x is 2. So derivative of 2x, it is 2 times e to the power 2x. Agree?
Yes,
Yes,
sir.
sir.
Yes.
In multiplication, we multiply by 2. I mean, in derivative, we multiply by 2. In integration, we divide by 2. So it is e to the power 2x dx is e to the power 2x divided by 2 plus c. Like this. E to the power 2x plus c. Okay, guys. See, now we are getting this thing in the middle of the example. So at that time, you have to have good command over some simple use of stuffs. So e to the power 2x is e to the power 2x by 2. Otherwise, you can go for u sub separately, but it's time consuming. So please be careful. Minus sine of integral by product rule. Integration by parts. Derivative of first means cosine 3x derivative. And integration of second, integration of v. Right? Derivative of cosine 3x is, derivative of cosine x is negative 3 sine x, negative 3 sine 3x. And derivative of 3x is 3, negative 3. Chain rule. In Calc 1, you went over your chain rule term by terms, and it took more than 3-4 steps to fix the derivative. But here now, you have to use the quick method and get it done very quickly. and integration e to the power 2x. See, already you found your integration over here. Just plug the same value over here, e to the power 2x by 2. Whatever constants I have in these integral terms as an integrand, just took it out. Negative out, positive. 3 out, 3. 2 denominator out, 3 by 2. But what? See, it's crazy. Again, I'm getting the terms e to the power 2x sine 3x. Means again u into v rule product of two functions. So functions Tesla, this is my v, this is my u. Again apply u into v. So we are applying u into v product rule twice in the same example. So it is 3 by 2. Now I have, see, I used the big bracket. And always try to develop your habit like this to write it down in separate brackets. So integration, derivative of sine 3x. Sine 3x is my u, so keep it as it is. Integration of e to the power 2x is about 2x by 2. Derivative of sine 3x is 3 cosine 3x. Integration e to the power 2x is about 2x by 2 plus c. Take this 3 by 2 constant, pull it out. Pull it out. So here it is 3 by 2. And you are getting e to the power 2x and cosine 3x like this. If you open this bracket with this one, this 3 by 2 with this one and 3 by 2 with this second term. So this is 3 by 2 sine 3 by 2 and 2, so 3 by 4. E to the power 2x sine 3x. And here it is 3 multiplied by this 3 is 9. 2 multiplied by this 2 is 4, so negative 9 by 4. E to the power 2x cosine 3x dx. But what is this? This is exactly the same example I started with. Look at there. Look at the beginning. And that's why I told you that just put the name I over here. So that I can use now I here. This is my I. Send this negative 9 by 4i to other side. So negative is positive now, 1 plus 9 by 4i. And this term is without derivative integral sign. This term is without that one and plus c. Simplify this one. 13 by 4i equal to this one. So I equal to multiply throughout by 4 by 13. So 4 by 13 and this one. But what was your I? Your I was your just the given example. So my I is this one. So integration is about 2x cosine 3x dx is this one. So this can be obtained only using the formula. That tabular form will not work over here. But in most of the cases, tabular form will work. Whenever you have some and derivative goes to 0. Some tricky example. Suppose I am asking you integration tangent inverse x dx. I wrote it down 1, but actual example is like this. Tangent inverse of x dx. Look at here. Tangent inverse of x dx. Okay. Good. Tangent inverse of x dx. How can you get the integration of this one? You know derivative of tangent inverse x, right? How can you get the integration of tangent inverse x? Derivative of tangent inverse x is 1 over 1 plus x square, right? I don't know whether you know this thing or not, but I'm going to teach you this thing in the hyperbolic function, the end of this chapter. Derivative of tangent, how to develop that derivative, how that derivative of tangent inverse x comes as 1 over 1 plus x square. I will let you know this thing. That is through the hyperbolic function. Anyway, so 1 times tangent inverse x dx, whenever nothing is mentioned at that time, you can write 1 because any function is multiplied by 1. And your 1, now don't follow Liet, just your 1 is your v. 1 is your v, and whatever the function is provided to you, tangent inverse x is your u. Tangent inverse x, that is your u. So u as it is, derivative or integration of v is x here, minus sign, integral sign. Derivative of u, tangent inverse x is 1 over 1 plus x square. Integration of v is x dx. So here you are getting x over x 1 plus x square. So 1 plus x square is u. 2x dx is du by 2. Or you can say this is my fx function. Numerator is f dash x, 2x divided and multiplied by 2. Okay. So we are getting like this, x tangent inverse x minus ln of absolute value of u plus c. Absolute value of u plus c, that is nothing but, yes please, I think I did something wrong. Yes, x dx equal to 1 by 2 du. So you have to have 1 by 2 over here. I'm sorry guys, my bad. You have to have 1 by 2 over here. It is my... Mm, 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 mm. 1 divided by 2, right? 1 by 2 du, because here it is x dx is nothing but du by 2. I forgot this 1 by 2, I'm sorry. That means you have to have 1 divided by 2, right? So plug the value of u 1 plus x square, and here 1 divided by 2, that is your answer. 1 divided by 2, that is your answer. Does it make sense?
Yes, sir.
Right, guys?
Sir, where's the 1 over 1 plus x squared coming from?
This one.
Yes, sir.
Who is there?
Veer?
Derivative of tangent inverse x is 1 over 1 plus x square.
Okay.
I think I told you I'm going to prove the formula in your hyperbolic function article 6.6, something like that.
Okay.
I think, yeah. Okay. Oops. Okay, guys, let's proceed further. Cosine of ln x dx. Cosine of ln x dx. If I take, suppose, ln x equal to u, now I am using my u sub and integration by parts simultaneously. If ln x equal to u, then x equal to e to the power u. This x is e to the power u. 1 over x dx is du. So x dx is x times eu, du. But x is nothing but e to the power u. So e to the power u times du. So whatever dx I have over here, this dx is now replaced by e to the power u du. E to the power u du. So e to the power u du, cosine ln x is u, so cosine u. So actually I'm working with e to the power u cosine u function, and then just apply the same rule. Oh guys, oh my gosh. I just wrote it down, this 1 by 2, 1 by 2, and that is over here. And it is just on the screen. My gosh. So it is just for this one, okay guys? Just 1 by 2 appears over here, not over here. I don't know, something goes wrong. Let me just, and I saved my screen. I should have not. Anyway, guys, but I hope you got this thing, right? It is 1 by 2 just over here. Just ignore this 1 by 2 now. Or let me close this file and let me reopen the same one. Do you want the save changes? No, I don't want to save this one. Okay. Now let me share the screen again. Where is it? Okay, guys, let me give you a break of 5 minutes, okay?
Yes, sir.
Yeah, break. Yeah. Yeah, I'm just working how to use this Vcom over here, but somehow I'm not able to fix this thing. Maybe I will do this thing very soon. Yeah. Okay, guys, let's start. Can you see my screen?
No, sir.
No.
No.
Okay, 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 okay. Okay, guys. So a number of examples are there. Just try to go through this one. This is U to V rule. Where I was. What about here?
Page 10 or 11.
Yep, page 10 or 11. Yes. Yeah, so we did this thing, and then after, look at here. Tangent inverse x, ln x. So this is converted like this. This is your u, this is your v. So u as it is, integration of v is same, e to the power u minus derivative of cosine u is negative sine u, integration is e to the power u. Again, you are going to use the same one. Consider this one as your I, and then take this I other side, just like your previous example. Just like your previous example, and finally you will get the answer. And page, what was the page number? 18, right? Okay. x, right? And now page number 19. Definite integral. Now, definite integral for the product rule, u into v rule. That means now the range of integration is provided to you 1 to 2 x square ln x dx. X is the algebraic function, stands first, and then after you have the logarithmic function stands first, LIATE. So this is u, this is v. Ln x as it is, integration of x square is x cubed by 3 minus derivative of ln x is 1 over x, integration x cubed by 3. Don't write c because definite integral is there. So I wrote down c and I cancel it because just to let you know. So x runs from 1 to 2. Here it is cosine x and x cubed. So x is replaced by upper limit. Then all the x's are replaced by lower limit and in between negative sign. So, or you can do one by term also. Here it is negative. So ln x and x cubed by 3 minus 1 by 3 out and x cube is x to the power. Something is wrong. Why? Oh yeah, it's okay. So 1 by 3 out here, x and x square will get cancelled out. X and x will get cancelled out. So we are getting x square over here. The integration of x square is x cubed by 3. So x cubed by 9. Here it is 1 to 2. Here it is 1 to 2. Or you can take the whole integration first and then take the range. Or term by term range will give the same answer. Here x is replaced by 2. So ln of 2 as it is and 2 cube is 8 by 3 constant out. Minus 1 by 9 and x cube is, otherwise it is 1. Look at it. ln 1 is 0. So that's why I did not write. Here it is x is replaced by 2. So 2 cube is 8 by 9. So 8 by 9 minus 1 cube is 1 by 9. So 8 minus 1 out over 9. Means we are getting 8 by 3 ln 2 minus 7 by 9. So approximately we are getting 1.07. That is the area of these two functions. Area of this function. Product of two functions. So this is just 1 times sine inverse x. Look at over here, the graph of sine function, and here sine inverse x is there actually. So I just multiply this sine inverse x by 1. So this is my u, this is my v. Sine inverse x, integration is x minus derivative of sine inverse x is 1 over 1 minus square root of 1 minus x square. Integration of 1 is x. If I want the integration of this term, let me use the u sub over here. Why u sub? Because power of 1 minus x square here, power is 2 here in denominator, and power is 1 here in numerator. So u sub will work because u sub reduces your power by 1. X sine inverse x 0 to 1 minus, this is 1 by 2 and du. Integration, simple integration, just power rule will give you this one. Replace your u by square root of 1 minus x square because that was your u. So 1 minus x square, u to the power half is square root of 1 minus x square now. Because your range is given in terms of x. This is the range of x, not u. So don't plug this u equal to 1 to 0. Please, this is x. I wrote it down specifically. Nick here, see here. X equal to 0 to 1. So sine inverse 1 minus 0 minus 1. Finally, this is your answer. So this is a definite integral. One more example. I think you can go over all these parts. And now we can start the trig integration. We can start the trigonometric integration. Trigonometric integration. You have to be very careful for trigonometric integration, guys. Please be careful. I will teach you just one part today and please work on this one. Otherwise you will be stuck and you will be facing problem in tomorrow's class. I request all you guys, please. Lazara, where are you? Okay. Judith?
Yes, sir.
Judith,
Yes, sir.
I can't see you.
Can you hear me, sir?
I can't see you.
My video's on.
I can see you.
Okay. Judith, yes. trigonometric integration, sine to the power mx cosine to the power nx dx, where m and n both are greater than or equal to 0. It could be sine square x cosine to the power 5x dx. It could be sine to the power 8x cosine to the power 6x dx. Whenever you have some higher power of your trig function at that time, how can you take the integration? So that is given over here in the trigonometric integration. Trigonometric integration. Sine, power of sine and cosine make big difference over here because power of m and n, suppose m is odd, n is odd, m is even, n is even, or vice versa, m is odd, n is even, and vice versa, m is even, n is odd. Whenever we are going to learn this type of integrals over here, be careful, be careful. Cooper, are you okay?
Yes, sir.
Yeah. Suppose power of m is odd. My first term, power of m is odd. And odd means 2k plus 1. And n could be anything. N could be odd, even, anything. But suppose power of m, sine to the power m, m is odd. Sine cube, sine to the power 5, sine to the power 7, like this. That means 2 plus 1. If I take k equal to 1, 2, 3, 4, 5. So 2 to the 2, 1s are 2 plus 1, 3, then 5, then 7, then 9, like this. Whenever you have power of m or 2k plus 1x like this, always save one sign factor. So 2k plus 1 can be written as sine to the power 2k times sine x. Sine to the power 2kx times sine x. And this is your saving factor. This is your saving factor. So keep this one aside. And sine to the power 2k can be written as sine square x to the power k. And this sine square x is converted to 1 minus square x. Sine square x is 1 minus cosine square x. Means this sine to the power mx can be written as 1 minus cosine square x to the power k into sine x. Into sine x. Okay, here? Into sine x. And we are looking for the integration of this term. So integration both sides. Sine x. Cosine to the power n, cosine to the power n. What is the advantage? If you do like this, that means you are getting this 1 sine square x is 1 minus cosine square x. And now you can use your use of for cosine square x. So cosine x or cosine square x, I think cosine x. So if you take cosine x, here, cosine x equal to suppose u. So sine x dx equal to your du. So this and this will give you du. Cosine x is u, so u to the power n. 1 minus u square to the power k. That means you are getting, look at here, 1 minus u square to the power k, u to the power n, and sine x dx is your du. Agree, guys? And then you can go for this integration very easily. That is the rule. Now other way around. Suppose your sine to the power m, I took m is odd. Suppose n is odd, not m, but suppose n is odd, then what will happen? If n is odd, that means n equal to 2k plus 1. Equal to 2k plus 1. Same technique, cosine n, cosine 2k plus 1, cosine 2kx and cosine x. Saving factor is your cosine x. Just separate one cosine x from this 2k plus 1. So this is your saving factor. Keep this one aside. So cosine 2k can be written as cosine square x to the power k, and cosine square is 1 minus sine square. 1 minus sine square. So if you are looking for integration, take integration both sides. So 1 minus sine square, and sine x is your u. Sine x, that will be your u. So u to the power m, u to the power m. 1 minus u square, 1 minus u square. Power k, power k. Sine x is u, it will be cosine x dx. That is your du. Once you get this one, that means integration will be very easy now. Integration will be very easy now. That is my second rule. If m is odd, sine is an saving factor. N is odd, cosine is an saving factor. Suppose m and n both are even. M and n both are even. Because here n is odd, m could be even or odd, anything. M is odd, n could be even or odd, even or odd, anything. When m and n both are even. M and n both are even, that means we are going to use the formula given to us in our formula sheet, page number 2, middle part. Cosine square x is 1 plus cosine 2x by 2, and sine square x is 1 minus cosine 2x by 2. Just use this formula. Use this formula and you can get the answer. Suppose m and n are odd. Both are odd, that means either you can use the first one or the second one. Just the first formula or the second formula. So these are the 4 forms, mainly first, second, and third. And let me take one example and we'll stop. Sine to the power 5x cosine to the power 8x dx. You can see over here, my 5 is odd. 5 is odd, right? I did not give anything for n equal to even or m equal to even. No. If it is odd, either this one or this one. If this one is odd, first formula. This one is odd, second formula. Both are even, third one. Okay. Both are even, third one. Both are odd. Suppose 5 and 7. Either one of these. Okay, so sine to the power 5x, cosine to the power 8x dx. Let me use the first one because 5 is my m is odd number. Sine to the power 5x can be 1. Sine is a saving factor. Sine to the power 4x and sine x. But sine to the power 4x can be written as sine square and square. Always try to make square over here. See, look at over here. That's what our formula said. Always try to make a square here. Sine square x. Look at here, sine square x to the power 4. So sine square x to the power 4. So I have to have sine square x. So here it is sine square and square. So sine square x times n square and sine x. Plug it over here. Sine to the power 5 is sine to the power 4 and sine square. Sine square is 1 minus cosine square. So 1 minus cosine square square. Sine x is my saving factor. Cosine to the power 8x as it is. And now cosine x is u, just by case 1. So cosine x is u. So negative of sine x dx is du. Send that negative sign to the other side. This is 1 minus u square square and u to the power 8 du. Perfect square, open it. 1 minus 2u square plus u to the power 4, u to the power 8. Multiplication term by term, u to the power 1, u to the power 8 times 1, u to the power 8. U to the power 8 times u to the power 2, u to the power 10 times 2. U to the power 4 plus 8 is 12. 12. Integration u to the power 8 is u to the power 9 by 9, u to the power 11 by 11, u to the power 13 by 13. Agree? 13 by 13. But u was nothing but your cosine x. So plug the value, cosine to the power 9x by 9, blah, 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 and answer. See, such a big odd and even power of the trig functions can also be integrated using this trig function. Using this trig function. Same here. Cosine cube x cosine. Now, of course, m is odd. Of course, m is odd. You can work with that one too. That m is odd function. M equal to sine cube x equal to m equal to 3. Or n is odd. Second part. N is 7, or so cosine to the 7 is cosine 6 and cosine x. Cosine x is your saving factor. You have to have square over here. So cosine square and cube. Cosine square is 1 minus sine square cube. So 1 minus sine square cube. It is a. Now, if you take sine x equal to u, du equal to cosine x dx. Cosine x dx. So you're going to get like this. 1 minus u square cube du. A minus b whole cube. A minus b whole cube is a cube minus b cube minus 3a square b plus 3ab square. That formula here. I think it is there in the formula too. I wrote it down plus and minus both the formula over here. Multiply your u cube with this bracket, all the functions. You're going to get this one. Term by term integration will give you the answer. Don't forget to plug the value of u, that is sine x. Both are even. Square and cosine square. Sine square is 1 minus cosine 2x. Cosine square is just multiply these two functions. If you multiply this, you are going to get square function. Cosine square 2x as a last multiplication. But you cannot work with cosine square 2x. Now I'm going to use again my formula on page 2. My cosine square 2x is the function. Because square is there, non-linear part, you cannot get the integration. You have to have the linear form, cosine to the power 1. So I'm going to use this formula, cosine of theta equal to 2 cosine square theta minus 1. This is one of the formulas in your formula sheet. Your formula sheet. Okay. I want square. That means I want this one. So let me make this one as a function. I'm going to get 2 cosine square theta equal to 1 plus cosine 2 theta. Agree? cosine square theta equal to 1 plus cosine 2 theta. Yes or no? Judith Gonzalez, I can't see
Yes,
you.
sir.
Okay.
Can you see me now?
Yes. Very frequently your video is off, so please be careful. Okay.
Okay.
This one. Okay, guys. Now you are looking for cosine square 2x. So let me divide by 2. So let me divide by 2. Now you're looking for cosine, not cosine square theta, but theta is your 2x. So replace your theta by 2x. So replace your theta by 2x. So you're going to get cosine square of 2x equal to 1 plus cosine of 2 and 2x divided by 2. So 1 plus cosine 4x by 2. 1 plus cosine 4x by 2. And that is nothing but, that's what I have used here. 1 plus cosine 4x by 2 and dx. Right? And I explain everything over here. Look at here. The whole part I explained to you here. If you come over here, 1 by 4, integration of 1 is x, integration of 1 by 2, that is x by 2, or 1 is x, cosine 4x is sine 4x divided by 4. Right? Sine 4x divided by 4. And simplify this one and you get the answer. So that's how you can go for the trig integration for sine and cosine. Sine and cosine. There are separate rules for trig integration for secant, secant tangent and cosecant and cotangent. Tomorrow we are going to start with tangent to the power m and secant to the power n x dx. Second part of the trig integration. But I request you, please guys, people are getting lots of trouble with these trig integrations. So please be careful. Go up to your sine and cosine trig integration, sine to the power m, cosine to the power n. And tomorrow we are going to start with tangent to the power m and secant to the power n. And we will be doing the same thing tomorrow morning. And then after, I'm going to give you Wallis formula. And then not the power, but then after we are going to see trig integration as an angle. Sine like this, sine 5x cosine 8x. Not power, sine bracket 5x cosine 8x. It's a different rule whenever you have a bigger angle over here. Sine and trig functions with an angle, bigger angle. There are different rules. Power is different, angle is different. So there are two different things we are learning right now. We are learning tomorrow. One part is done today and rest of the things we will be doing tomorrow. Is it okay? Any doubt?
No, sir.
Sir, I had a question real quick.
Yes, please.
Did you say you were sending out the practice examples today or
Yes.
tomorrow?
Most likely today, otherwise tomorrow's journey.
Thank you.
No problem. Yes, any other doubt? Okay, guys, shall we stop here? Take care, guys. Work hard. If you have any doubt, all you guys, please be attentive, be particular. If you follow me, you will enjoy this course. Thank you, guys.
Sir, I have a quick question about the test.
Yes.
I didn't see the comment saying that you couldn't find my test until this morning. And
Have you submitted your test on Canvas?
yeah, it's on Canvas. They just said you couldn't find it, and I guess I sent too many files. So would you like me to email? So you can...
No, I don't accept exams on email because I want to have some proof with us that you submitted your exam and I graded your exam.
Okay, well, it's not.
Please,
it's
let me finish. It's not hard. If you want, you can take the help from somebody else from our section. Just ask somebody, because all the guys, they submitted online. Why are you facing problem? I don't know. So just ask them and please do submit online. The window was closed for your submission yesterday night. I'm going to open that window probably very soon. Okay, so just try at 12 p.m. Oh, sorry, 12 p.m. Around that time, I will open the window for you. But you have to submit, and please make sure you have to submit just 2 files, not more than 2. Okay.
Would you like me to submit it in a folder with everything in it?
Say again?
Submit it in a folder with everything in it?
Not folder. I think you can submit just 2 files. Just one by one, take the pages, just scan the pages, 10 pages. And I think that's more than enough. Just 2 files.
Okay.
Okay. Yeah.
Yeah.
Somebody, if you want to take the help right now, I don't mind. Just ask somebody and yeah, and please do submit.
Sir, is there any way we could receive any feedback about the test or the homework? About like our particular test or homework?
Check your test. You will find one balloon. Whenever you find balloon at that place, I put your points, your grades, and your some comments too. If cross is there, then that part is wrong. If you have submitted on Canvas. If you have not submitted on Canvas, you can't expect that thing.
Sir, I see the bubble. When I click on it, I also see my grade on the homework. But I don't see beyond that, like which particular questions I got wrong, just so that I have some way going forward
Are you
with
sure?
this next unit.
Did you submit your exam on Canvas yesterday? I don't think so. And that's why we had lots of chatting, right?
No, sir, I did submit it on Canvas eventually.
You did submit on Canvas, but that is after lots of emails, right?
Yes, sir.
Not at the initial stage.
No, it wasn't letting me initially. Initially, I submitted through email, and
Let
then
me do one thing. Let me go through your exam again today afternoon, and then after we will discuss. Okay.
So I have the same thing, and I didn't email you. It literally just says -4, not what I did wrong or anything. It'll just say minus however many points.
Okay. Let me see. Cooper and okay. Let me see. Okay, guys. Anything more? Okay. Thank you, guys. Ismail, make sure you have to submit both your exams. I'm going to open the windows around 12 noon. So please do this thing. This is the last chance. If you don't want to submit, that's fine.
Sir, can I say something? So I'm on my Canvas right now, and
Right now the window.
I'm able to pull it up.
Listen to
Like
me. Right now, window is closed. You can't upload your exam right now.
No, I already uploaded my exam, but I'm
Then
saying I'm on my Canvas right now, and I'm able to look at my exam.
I will
So-
double check and let you know. I will double check and let you know. But
All
yes,
right.
you did not submit any of your exams. When did you submit the exam?
I submitted both of them on time.
In the
I don't
morning and
know.
today? Today?
No, yesterday.
No. I did not receive any of your exams. No. Make sure. I got all other exams except yours. I did not your exam in for Calc 2 and both of them. Please make sure. And that's the reason I sent the email to you. Okay, guys, I have another class, so please let me stop over here. Okay? And see you tomorrow at 7:30, 7:35. Is it okay, guys? Girls, are you okay?
Yeah, that's fine.
Sir, I had a quick question.
I have another class, guys. Please go ahead.
Yes, sir.
Last question. Go ahead.
I was going to ask if you close the Zoom, are we still able to communicate after you've left? Because I was going to help somebody fix their submission problem.
I'm not getting you. What you said? Your voice is getting echo.
If you leave the Zoom call, will it still be able to continue so I can help someone else submit their Canvas?
Oh yeah, that sounds good. Yeah. So you want me to continue this Zoom call?
I was going to ask if you leave the Zoom call, will it end for everybody?
Yes, sure. So do one thing. I have another class after 15 minutes. So let's do one thing. I can give you 10 minutes. If somebody wants the help, please take the help from him. I really appreciate. Thank you so much, Kev. I really appreciate.
Yes, sir.
Yeah, so I keep this Zoom call on and yeah, take the help from him, guys, and please appreciate him. He is a nice guy. See, without asking, he's helping you guys. I really appreciate. So nice of you. I like your gesture.
Okay, you guys were having a
I'll be
problem.
back in next 10 minutes, but by that time, please try to finish all these things, okay? Because I have to
Yes, sir.
start another class.
So you guys having a problem submitting to Canvas or with the files?
Like I scanned it. I have a bunch of like pictures of it. I don't know how to put it in one format thing.
So what app are you using?
It's like a scanner app. I don't know if it's the same one he said. It's the
I've got
Tiny scanner.
ScanBot, something like
Yeah,
that. Yeah.
yeah.
So what I did, I was a little confused at first because you can't send more than one PDF at a time with that app. I saved all of mine into a PDF for like homework, and then I did another one for test, and then I sent that to my own email, and then I submitted it on Canvas.
Okay.
Because
Yeah, I told you,
I tried doing it all
you
through
have to
the app,
first
and it
send
didn't.
to your email, and I think that is the best way. You first send to your email and then submit to the Canvas. I told you yesterday. And
Okay.
Scaff, Chris, yeah, what's your first name?
Charles, sir.
Charles, I'm sorry. Charles, let me do one thing. Let me open the Canvas right now, Canvas window right now, so that these guys can submit in your
Okay.
hands, right? Let me just open the window. Just wait. Yeah, it was closed yesterday night at 9. Okay, let me open this one for today. And done. And this is exam year 124, okay. And it is published. So let me save this one. Yeah, it is open now. So you guys can submit right now. I'm going to close after an hour, so please do it right now.
Ish, I had a question about how you submit your files on Canvas because I know there's two ways, and I know that doing one of them has screwed me up a couple of times in the past. When you submit, there on the right side is the immediate option to attach files. Did you do that, or did you hit submit assignment and then attach a file?
I submitted like 17 files. Yeah.
I submitted it off my phone. So as soon as I got finished
Yeah.
scanning it, I just submitted it straight through to Canvas.
Oh, like straight through the app?
Yeah.
Oh, okay. I don't know. What app are you using?
ScanBot.
ScanBot? Did you do it all as one big file?
No, so I did two different files. So it was one for the test and one for the homework.
Okay.
And I tried submitting them twice through the same assignment. And I guess he was only able to see the homework.
I know that when I tried to do that, like my ScanBot like just crashed whenever I tried to do two PDFs. Like I tried to do my homework and my test PDF.
Yeah.
So what I did was I scanned in all my tests and then I sent it to my own email, and then I did my homework and sent it to my own email. That way I could open it on my laptop and then submit it in Canvas from there. Because whenever I do more than one file on ScanBot, it kind of crashes.
All right, I figured it out. I accidentally saved them as pictures, not PDF.
Okay.
Yeah. All right. Oh, I think that's it. Thank you.
Yep.
All right.
No problem.
See you tomorrow.
Ish, did you get it figured out?
Yeah, I'm gonna try it right now.
All right. Is it working?
I just emailed them to myself, so I'm about to see if I can submit them now. I don't know. If you said it worked for you, then it should work.
All right. I'm gonna head out then. If you got it going.
All right, man. Thanks.
See you.
Yeah, but what's the timer on for the?